Hey everyone, welcome to our second community office hours. We're glad you're joining us. We've got some questions in already. If you have anything you'd like to ask as we're going along, please feel free to use the Q&A option that you'll see on your screen in the Zoom menu, or we have the channel Office Hours in our community Slack where you can ask questions live and get answered. We've got some returning panelists and a new panelist today, so I'm going to let everybody just take a moment to introduce themselves. Michael, you want to kick us off?
Sure. Yeah, I'm Michael Desa. I've been with Influx for a little bit over 4 years. Actually, Gunner is probably one of the 5 people at the company who's been here longer than me, so it's awesome to have him here today. And just recently, I transitioned roles to being the engineering manager for the front-end application, so super excited about
that. Yeah, I've only been here just slightly longer than Michael for 4 years as well. And right now, I'm the manager of partner engineering.
Hi, good morning. My name is Jacob, and I'm a software engineer on the storage team, and I've been at Influx for 1.5 years.
And I'm Tom. I'm the community manager here, and I started back in March. So let's jump right into some of these questions we've got. First question is kind of an exciting one, and I know something that Desaad has been working a lot on, and that is InfluxDB 2.0. We had somebody ask what's new in 2.0, and why would I consider going to 2.0 from 1.0?
Yeah, so I think the big thing for 2.0 is the making a multi-tenant SaaS platform of the previous products, where instead of having to buy this big cluster or set up a whole instance, you can really do basically pay-as-you-go pricing. So you only pay for the resources that you consume in the cluster, and I think that's going to give a lot of people the opportunity to kind of just try stuff out. Which is really cool. There's a free tier, so there's a tier that's entirely free for people to use, which is super exciting and super cool. On top of that, it has the exact same API as the OSS version, so if you want to kind of play with OSS for a little bit, then go to cloud, or use cloud and then go to OSS, the kind of story between those two should be very fluid. So that's kind of what I think is super cool and exciting.
Awesome. So it's fully managed. On the cloud 2.0 is fully managed, whereas if you're doing open source, you have to manage all of that setup and everything yourself, right?
And so to add a little bit, maybe more color to that. So we used to have a cloud version of the product, but it was more managed hosting, where what we did is we spun up a cluster for you, and then that was your cluster. And what we started to see is that we had a lot of clusters that were extremely overutilized, and we had a lot of clusters that were extremely underutilized. And so we wanted to kind of bridge that gap so that you only ever paid for the resources that you really used in the cluster, rather than just having this kind of set of machines that are just sitting there not really doing anything. So I think that's one of the things that's really cool about our 2.0. And then the free tier I think is especially cool. So there's an in for anybody just to kind of get started, and it's useful enough that you can kind of put data in from about 10 or 15 different machines, collecting various metrics from Telegraph. So I think it's very cool. It's a nice on-ramp into getting into the platform.
One of the users in our community asked, it says on the free plan that it stores 72 hours of data, but how is that measured? If I connect a running system to it, which pushes data to the DB in real time, it's clear. But what if I populate the DB via an API with predefined timestamps? If I push metric with a timestamp from a week ago, how will this case be handled?
Jacob, you want to handle that, or you want me to grab that?
Yeah, so I don't think I've actually tested this in particular. Another engineer may have done it. But certainly, if you try to write data that's older than your retention policy, which I think is what we're talking about here, 72-hour retention policy, the data should not show up. So either you'll get an API error, an error returned to your call, or the data will just simply not appear, not never be queryable. Or worst case, it'll appear to be queryable and then disappear on the next compaction event, which is the thing that I'd like to check after seeing this question to make sure that that's not what happens. But retention policies are funny because in for example, in more rectangular databases, if you will, SQL databases, there is not this idea that you automatically delete data like after a certain period of time, right? So time series in general, you have to get used to this concept of, well, we're laying down data. We're laying down a lot of data every day, and probably not going to find it useful at some point in the future. So let's just automatically throw it away, and that's something to get used to, I think, for time series in general. But 72 hours is I think it's a fair retention policy for the free tier.
And as we go out of the beta option, people are going to be able to set their own retention policies. Is that correct?
Yeah, maybe Gunner has visibility on this. What's on the business side? What's our?
Yeah, I know that there will obviously be expanded sort of data retention once we go GA. I can't say for sure what the final decision was on the free.
Gotcha.
Yeah.
But with the free plan is in beta right now, so it's not meant to be a full production use database anyway, right?
Yeah.
Cool. Someone asked, since they can create multiple databases, is there a general rule of thumb applicable to time series databases or InfluxDB in particular on when do I need to create a new database? More importantly, how to be able to measure when a new database is needed and when one does not suffice.
Michael, you want to pick that up, or you want me to go for
it?
Yeah, so in general, in InfluxDB, sort of the rule of thumb is unless you have a completely different, say, like use case or team that is using the database, we would almost always recommend you just keep everything in the same database. InfluxDB is, we have this concept of tagging and measurements and 1x, which is basically meant to be sort of an encapsulation of essentially like a source of data in a sense. So like the CPU measurement, for instance, or memory, if you're collecting any kind of telegraph system stats. And even if you have multiple telegraphs, for instance, set up, both for some specific use case that you're doing, but also for, say you're collecting stats in region 1 of your data center or region 2 of your data center. The easy way to sort of split that up is to just tag it with something like data center equals 1 or data center equals 2 or data center equals US East 1, for example, and then store that all in the same database, and then query. It makes querying much easier because you don't have to switch databases every time you query, and it's simply just adding a where filter to make sure that you're filtering out for the right data. And ultimately, not only does this make the query experience better, but it'll lead to overall better performance in your InfluxDB 1x at least. 2.0, we actually have sort of rearranged things on the back end. Michael can sort of talk to that in a second, but in InfluxDB 1x, every database sort of has a bunch of sort of buffers in memory, as well as things going on behind the scenes that take up resources. And so, files are opened, all that kind of stuff. And so every additional database that you create adds another essentially like layer of this overall sort of bookkeeping that just needs to happen for each database. And so the fewer databases you have overall, the more utility you're going to get out of a database if you're just putting all your data into one database. Now, when would be a good time to actually have a separate database? Typically, it's we see the best times to have separate databases is if you have, say, a separate team that is doing something completely unrelated to and what another team is doing. And usually in those cases, we recommend setting up separate databases. So the database concept is almost sort of, it's best to think about it as almost a more administrative separation than a data separation. So if you're a, say, internal team at a company and you want to provide, say, your web analytics team with some InfluxDB goodness, and you also want to provide your SRE team some analytics goodness, then you'd probably set them up on separate databases. But in terms of within those teams, in most cases, it almost always makes sense to have one database for them to use at a given time and store all that data in there and just separate things out by measurement and tag.
Can you speak briefly to what a measurement is? Because I think that's something a little more, or what a tag and tag set is, so that people understand how that works.
Yeah, in InfluxDB, basically, you can just think of sort of tag sets as the way data is indexed in InfluxDB. So in terms of searching up data very fast, anything that's tagged makes it super easy for InfluxDB to immediately pull back and identify where that data is and pull it back very fast. And so in particular, if you're talking about time series, every single time series is, at its core, a set of timestamps values that are stored basically you can think of it in like a contiguous line. In that sort of series, that individual sort of series is the way that InfluxDB stores it is very efficient on disk and also efficient to query and write to. And so, but when you're looking at, if you have thousands or hundreds of thousands or millions of these separate different series, you want to be able to look up and identify, any particular series, say like the CPU usage for CPU 1 on some specific machine. You want to be able to look up and identify that exact series very fast. And so tagging is the way to do that in InfluxDB. And what tagging is just a set of key value pairs that you've assigned to a series, or in this case, a series is just a tag key, which identifies essentially underlying set of sort of variable data. And then that tag value, key value pair essentially is what you can use in your queries to quickly identify the series that you want to pull back in a query, and allows InfluxDB to basically the way, and Michael and Jacob could probably expand on the actual underlying mechanism of that. But essentially, if you look at a measurement is part in 1.x InfluxDB. A measurement is required on all your data, and you can just think of it as measurement as one of a required key value pair, where the key is measurement, like literally measurement, and then the value of that measurement key is just the name of the measurement. And so in 1x, that's the only required tag, essentially, is the way you can think of it. And in 2.0, that's changing slightly. Does that sound right?
Yeah, totally. I think the one thing to add, just kind of very high level, is it's essentially just index values, right? And so it's just a way that whenever we see this particular value, we can point to a series and say that this value is associated with this series. That's kind of, as Gunner said, that's the high level idea there.
So going back to our original question, what you would do instead of creating a new database is utilize the tag sets and query against the tags to get the data you want, as opposed to creating a new database for all of your use cases, right?
Yeah, new measurements, new tags, I think would be a good way to go. So one thing to add kind of to that a little bit is, and Gunner said this, is if you're aiming for like raw performance, you definitely want to just have one database for all of your data is going. If you're aiming for access control, then dividing things into separate databases is usually a good option. However, it is something we kind of urge people to not do so much. So we've had customers that have put hundreds or thousands of databases, and what ends up happening in production use cases is you get a lot of thrashing on disks, since all these things are in wildly different parts of the file system. And if we're doing scans or inserts or writes across all of them, we start to see a lot of degraded performance. And so for that reason, if your target is performance, you want to minimize the number of databases that you have.
And I do want to touch on something else as well, is a use case that we see often, or a setup that we see often, is someone has some service that they're putting together and they want to provide, say, they've got a bunch of customers. It's like some SaaS service, and they got a bunch of customers that they've signed up, and they want to provide like customer X, customer Y, customer Z. Each has their own data, and they want to provide access to that data by the customers. And generally, sometimes what people do is they'll set up a separate database for customer X, Y, and Z, even though essentially in their app, they're always writing the same sort of data because some SaaS service that's filtering what's coming in. And they're only allowing the same sort of types of queries and stuff like that. So ultimately underneath, the data is very uniform, but they, you think of, okay, well, these are different customers. Maybe, this is something where we do actually need separate databases. That's not always the case. So if you can think of the data, if the data underneath is all the same, in that case, we'd, generally in InfluxDB, you want to keep your data for customer X, Y, and Z as just separate tag data in your database for, say, have literally a customer, like a tag value pair of customer equals X, customer equals Y. And then in your SaaS app, which hopefully you have some kind of routing proxy that's going through your requests and rejecting ones that are invalid in some way. That's where you should put your basically auth control and validate that you're attaching on every query, the right permission or authorizing access for the right people to the right data in your app layer. And just for a quick pitch, InfluxDB Enterprise does have a sort of like fine-grained auth option that could work for you if you do need sort of to set fine-grained permissions to certain tag values within a database, and you don't want to put that in your app layer.
While we're talking about how we're doing using tags and tag sets and measurements, somebody asked a question I hadn't really ever considered, and that is, can I have too many tags in a tag set? How many tags or too many tag sets in a database? Or is that something people should look out for, or how does that work with InfluxDB?
So too many tag sets sounds like high cardinality.
Mm-hmm.
But too many tags is, yes, you can have too many tags for a particular bit of data, but that's hard to reach without making like some code mistake. So cardinality is certainly something to avoid. So watch out for too many tag values, for example, tag key value pairs. And that's been covered, like that's a dead horse for sure. And I forget what the limit is, something like 10K is the length of a line protocol line, the maximum line protocol line, something like that.
So I've heard that number before, but I remember a while ago I was playing around and it didn't seem to hit that number. Okay. But that's that number I've heard as well.
Yeah. But that's just being irresponsible. I mean, make your tags make sense, right? And don't let code generate tags for you.
Yeah, like Jacob mentioned, it's like this is gone. There's a bunch of stuff in the docs on this about sort of tag cardinality and series cardinality. So basically, the number of tags that you have is ultimately the number of underlying series, which are those sort of like base level segments of data. And that series cardinality is ultimately what drives a number of like resource usage parameters within the database. So primarily memory usage, just as the index holds basically references in memory to those underlying data strings of values. And so as you have larger cardinality, you have more memory usage typically. We do have an index that can scroll out basically certain scroll out references that were least used, and that's called the TSI index. It's an option you can set in InfluxDB 1x, and it's on by default in InfluxDB 2. And so that'll eliminate if you have very, very high cardinality, but you never access those series, or very rarely access those series and very rarely write to those series, then it can allow, then this new index can allow you to have a significant number of series with a much smaller memory footprint. But ultimately, in terms of like the upper limits of sort of tag key value pairs, there are some sort of hard limits, and like Jacob was saying, there's some hard limits in terms of like the longest size of line protocol you can have. There's some hard limits on like the number, the like size of a tag key and a tag value, but those are fairly large, and I think those are in the docs somewhere. And so effectively what that means is you're almost always limited by the amount of memory you have on the system that you're running Influx on. And so ultimately, we haven't seen a point yet where there's sort of a database imposed limit on the number of series that you can include in an InfluxDB instance. It's almost always hardware limited, where there's just not enough memory on the box for InfluxDB to keep all the series references in place at a single time.
Very cool. Well, let's switch gears just a little bit. And we had a question about Telegraph. And the question said, is it possible to make Telegraph remember which files have been loaded into Influx? This user had huge files archived with many thousands of files and wants to load the data from beginning to end. What happens is that even with the high buffer limit, it fills up, and the files that have already been imported get imported again. So the data is totaling around 30 gigabytes split in CSV files, around 1.5 megs each. And ideally, he'd like to have the logic that removes files from the data directory after they're loaded. Is that something that
is this a feature of Telegraph to consume from files, from CSV files?
Yeah, there's a file, but
is that what the user's trying to do, is what I'm asking?
I think so.
Yeah, it sounds like they've got the file input running, and then every time they're running the file input, it's re-ingesting files that maybe have already been ingested. Yeah, I think this might be a feature request.
Okay.
We could probably follow up on if this is in. Maybe Michael, do you know anything about this?
No, yeah, it sounds to me like a feature request, and it seems like they have some static data and they want to have that data loaded into Influx. Maybe Telegraph can do that, and that's the way to get it done, but I suspect that it might be, if it's already in kind of CSV format, it might be easiest to just do a little bit of kind of scripting and just generate some line protocol from the CSV. And kind of just load it in manually. Possibly there would be a feature request we could add to Telegraph, and maybe it already exists. I'm just naive to that. But it seems like it's kind of like a batch one-time job thing that you want to do, right? Where maybe using Telegraph isn't the best use case for that.
I just found the plug. I think the plugin that's being referred to is called inputs.file. And it does take a list of files and then a format, and that's it. So I agree with Michael. This is a one-off job with a lot of data. So write your custom script and make sure that it gets in properly, because I don't think that Telegraph was made to do a lot of this.
Cool. So it just goes to show that just because you have a hammer, not everything is a nail. You got to use the right tooling for the right job, right? And Telegraph may not be that perfect one-size-fit-all for all use cases. We did have another question, and that was, is there a way to make Telegraph consume raw stats.d data instead of raw aggregate data? And this was something I was looking at personally, so I'll take it, and I will say no, there is not. And that's an issue with how stats.d, their parser and aggregator are combined together. So whenever that data comes in through Telegraph, it's already aggregated, and that's not something that Telegraph is going to be able to unaggregate. And I'm going to check.
Is that essentially they want to use Telegraph as a stats-D replacement?
Yes, they want to take all that. Yeah, and they want to take all the data that they're getting that's already pre-aggregated from stats-D and unaggregate it.
Got it.
Let's see if we have any more questions lined up yet. I'm not seeing. I'm going to double check our community page.
I do want to just go back and touch on the question around series cardinality and
yeah,
tag value pairs. I do want to just mention that there are some built-in limits in InfluxDB that we set by default that basically limit the number of tag value pairs that you can have. It's basically just configuration setting, and we have that in there essentially just to make sure that people aren't creating sort of a huge number of tag value pairs, and when they do, that they are aware that that is happening. So that's all in the configuration file. If you have extra memory, feel free to raise those limits or set them to infinite, which I think is just 0. And so if you are, and usually if you do hit any of those limits, those will show up in the log file immediately. So just something to be aware of, especially if you're like stress testing, for instance, InfluxDB. That's something you can hit. Tom, I think you're
one of our attendees asked in our community Slack in the office hours channel. He said, I have 7 hosts, and in 2 hosts, the NCPU in system plugin is fluctuating between 2 and 8. He says, actually, those 2 hosts have 8 CPU cores. So the N_CPU value should be 8, and it should be constant. The similar behavior he noticed with disk used percentage is in the tens interval. The used percentage is going to 37% from 19%. And the next tens, it's coming back to 19%. They're also seeing the same behavior for uptime. Instead of a smooth ramp up graph, it ramps up and jumps down for some data points, then jumps up, then back down. Have y'all seen this before? Is this some sort of bug he's encountering, or is there something he can do to smooth that out?
I would ask how was the graph that he's making this being generated? To me, it sounds like we have a query that is not grouping by star. And so essentially what we're doing is we're seeing like there's multiple series that are getting combined into a single visualization. And so the metric gets all messed up. So whatever query he has that they're using to visualize, just throw a group by star at the very end of that. And if the problem still persists after that, then we might have a bug. To me, for the system plugin, it would be pretty bizarre, but nonetheless, it is possible. So I would guess that it's a query problem that we're experiencing, where the query that we're issuing makes it look like the data is not what we expect it to be.
Yeah, I agree.
Perfect. I hope that helps, Josh. And we've got one user typing a question right now. Josh says he can see in the raw data the jumps.
So like select star, group by star, select star from thing, group by star, and there's still jumps in the data.
He says he's seeing it he says he can see the raw data. He can see the jumps in the database itself.
How? That's what I would ask. Like, what's the query that you're issuing to see that?
And I think for the, we're waiting for a response from Josh, but I think we may need to, oh, he's got an image. If you'll check the Slack, Michael.
Yep. So I'm looking at that. That's the data itself, but can we get the query that was issued to get that data? Might be best to kind of take that one offline. I'm happy to follow up on that in the actual Slack channel, because I think there might be a bit more interaction that needs to take place.
Perfect. So Josh, we're going to look at that a little more in depth. Hopefully the question helped, or the answer that we've given helped some users. As for now, I think that wraps up all of our questions. So thank you everyone who joined us today. We're going to go ahead and edit this. If you're listening to the edited video version of it.
Somebody raised their hand in the attendees.
Oh, there we go. Okay. Let's see. Siam. Okay. You can now talk. We can hear you, Siam. What's your question?
Hello?
Go
Hello.
ahead. Yeah, we can hear you now.
Oh, great. Yeah, I just saw the post that the office hours is happening. Maybe I got it in the right time.
Yep, you're right on time.
Yeah. So I posted this question some time back in Influx section. Like I have a question regarding the Flux query. So I don't know why, but I have written a Flux query just to get some of the metrics from the Kubernetes pod container, but it actually crashes my pod and nothing happens. Even Scott tried to help over there and customize the Flux query. Even we tried for the time less than 1 hour, but still the container got crashed. So I'm not able to figure out does really the Flux query take so much of time or how it is, so much of memory.
Using this, writing this Flux query against a 1.x or a 2.0 database?
Yeah, it's 1.76.
Okay, 176.
Yeah, I can just quickly find out the Flux query as well. It's in the Influx InfluxDB channel.
So this is a simple query, and it takes a long time to return, or it never returns. Is that the case? Is that what's happening?
Yes.
Okay. So the version of Flux that we ship with 1.7 is not as up to date as other versions, and I know performance has been a concern. This sounds like a much more serious performance problem than I would imagine. Have you tried even going down to like 1 minute rather than 1 hour just to see if the query will return anything?
Not 1 minute, but 1 hour I tried. It didn't work for 1 hour. I'll try for 1 minute as well.
Yeah, just to see if it's syntactically correct, you know.
Yeah, syntactically, actually, it should be correct because Scott verified it a couple of times, and there is a very long conversation that we had over there. So the query should be right. I think so. Okay.
So now I would want to look at.
Yeah, and ultimately, I think probably this sounds like something that issue might be worth setting up on. If this is, we haven't seen the query yet, but if this is something where performance is potentially an issue, maybe there's some.
Yeah, so I have the query. I can actually post that.
Sure, go ahead.
Quickly. So instead of -2D, we tried different ranges, 1 hour as well.
Okay. And are you posting that in the office hours channel?
It's in the Q&A.
Oh, sorry.
Okay, perfect. Okay, see, there we go. Perfect.
Where's the Q&A?
There's a little Q&A button at the bottom of Zoom.
Okay.
Yeah.
The left of the share button.
Got it.
So it goes back for the last 2 days, does a filter.
Yeah, even reduced back to start minus 1 hour, but didn't work.
Yeah, this looks pretty simple, right? Like this doesn't look particularly crazy.
So I'm not sure, and the container itself, I'm not doing any wonders with the container. I'm not giving any additional parameters, just normal container has been started and it has metrics. By the way, when I run these queries separately for 30 days, it works perfectly fine.
Interesting. So it's likely the join that's causing the issue.
Yes.
I do see on the join that on the second argument, it says CPU alloc, :CPU p alloc. I wonder if maybe that's
No, that is just so if you see the first variable is CPU util, that's why it's CPU util, and second one is the alloc. That's why it's just
I see. Okay, got it.
Just the names.
Yeah.
Yeah, that seems pretty mild in my opinion. If you are experiencing issues with that, you should definitely, if you could open up an issue on the Flux repo and then just kind of add some documentation about what happens, and should maybe like a memory profile or CPU profile while the query is
Yes, everything is there. I mean, in the InfluxDB channel, there is a 46 replies thread between me and Scott. And I posted my CPU and memory utilization also. It went up abnormally 794%, showing some vague numbers, and then it crashed.
Yeah, so I think probably makes sense to open up an issue on GitHub for this one.
Sure.
Who's Scott? Because we could follow up with Scott. Is this Scott the guy who writes docs?
Yeah, I think so.
Okay.
So yeah, I think, let me type at the rate. Yeah, Scott Anderson.
Yep.
Perfect.
So I think he's an InfluxDB guy because he has that logo in front of his name.
Mm-hmm.
Yep. Yeah, he's one of the docs writers here for us, and he knows a lot about Flux. So I don't see anywhere specifically where this will be referenced, but the best kind of course of action, because that query, in my opinion, looks very standard and shouldn't cause any problems. So if you could go to the Flux repo, I'll kind of maybe send that to you right now, and just kind of open up an issue with that, just kind of just in detail. But that's going to be the best course of action to get the Flux team actually looking in on it and addressing the problem.
Sure. I'll do that.
And I've just pinged Scott so that he can help sort of carry the context into that issue.
Sure, I'll create the issue by today itself.
Okay.
Perfect. Thank you. And just so you all know, Siam is our
go ahead.
head of our new Influx Bangalore community. So he's heading up and
Awesome.
Oh, cool.
Bangalore.
Oh, wow.
Very cool.
Big advocate for InfluxDB there in Bangalore. So
that's very cool.
And I also want to
had conversations prior, so we have met on Zoom and everything. So yeah,
very cool.
Cool. And I also want to just add that cases like this where there's some discussion on performance and stuff like that, especially because Flux is we're still smoothing out some bugs and stuff like that and all that. It's definitely fair game to open up issues on GitHub about this kind of behavior where you've sort of narrowed down the different possible issues, and if a couple of people can't see where something is going wrong, I think that's the kind of stuff that we'd like to see.
Yeah, this is like gold. So please do open up that issue, Sam, because we need to dig into it properly.
Sure, I'll do that, because I wanted to do pretty complex stuff but I had to start with simpler one. So the simpler one only hanged up. So I thought, okay, now it's difficult.
Yeah. And join is a great example of where Flux can,
Yes. I actually wanted data from different tables into an Excel, because chronographs gives you very flexible way to export it as an Excel. So it would be simple if I can join the tables, do some calculations, get some data directly into the Excel. So that was the whole approach that I wanted to do.
Awesome. Thanks for bringing that up, Sam.
Yeah, thank you very much. Perfect.
Thank you, guys.
And I'm checking one last time. We have no more questions. That was good. Thank you so much, Jacob, Michael, and Gunner. We appreciate you all taking time to help and answer some questions. Again, if you're watching this as the video, we are hosting our monthly community office hours on the third Wednesday of every month at this time, right at 10 a.m. Central Standard Time. And we look forward to having you on next month. If you have any questions between now and then, feel free to reach out to us on Slack. We have a community office hours channel if you'd like to ask some more in-depth questions. We've also got our forums where we scour looking for discussion topics, and our Reddit. So feel free to reach out, and we will see you all next month.
Thanks, Tom. Have a great day, guys.
Thank you, Tom.
Bye, everyone.